So what I've written, when right hand side of x does not belong partially or completely to any one of the above types, then we shall use partial fraction method, or we shall use partial fraction method. Okay, what is the partial fraction method? That is number one, that is pi, and this equal to what? This equal to 1 upon d minus m x, and this equal to e raised to mx integration of x into e raised to minus mx dx. Okay, or second one, pi equal to 1 upon d plus m x, and this equal to e raised to minus mx into integration of x e raised to mx dx. Okay, when the right hand side of your differential equation does not belong to any one of the form, then we will use this technique to solve the differential equation. Okay, so let us do one problem based on this, then you will understand the concept easily. Okay, so write on the problem, solve or find pi. Just example number one. Okay, find pi, particular integral of the differential equation dE. Your differential equation is what? D square y by dx square plus 3 dy by dx and plus 2y, and this equal to e raised to x, x. What I have to do? We have to find the particular integral. Okay, so write down the solution for this. First of all, we will copy the given differential equation. What is the given differential equation? D square y by dx square and plus 3 dy by dx and plus 2y, and this equal to e raised to x. Okay, so this can be written as d square y and plus 3 dy and plus 2y, and which is equal to what? E raised to x. Okay, now we'll take y as a common from each term, so we'll have d square plus 3d and plus 2 into y, and this equal to e raised to x. Okay, see here, the right hand side is what? Exponential function, e raised to x. This function does not belong to the any of the form.
सर वो डी स्क्वायर वाई अपॉन डी एक्स स्क्वायर कहाँ गया? नीचे एक्स डी एक्स स्क्वायर था ना सर वो?
हाँ, वेयर यहाँ पे आप लिख सकते हो, वेयर d by dx equal to d. Okay, this is the differential operator na, so you can write like this. Yes or no?
यस सर.
हाँ, so what I have to do? We have to find a particular integral. Okay, I'm not saying that solve the differential equation, so you don't need to find complementary function. Okay, if I ask solve the differential equation, then you will write the auxiliary equation and find the roots of that auxiliary equation. Getting? Then you will have the complementary function. Your complementary function will be c1 e raised to minus x plus c2 e raised to minus 2x, because minus 1 and minus 2 are two roots of the given differential equation. Okay, so here we have to find only particular integral. So let us find the particular integral. Particular integral pi. Okay, pi equal to what? 1 upon 1 upon d square and plus 3 d and plus 2. Okay, into e raised to x. Okay, and this can be written as what I have to do here. We are using the type number 5, so we will use this techniques. Okay, so we must factorize this. What is the factor of this? So d square plus 3d and plus 2. Okay, so we will have d uh, plus 1 and d plus 2 is a factor. Getting? So we will use here. So this is what? 1 upon d plus 2, 1 upon d plus 2 and d plus 1 into e raised to x. Okay, so just use the above formula. So see here. Now this equal to, I am keeping first one aside, d plus 2. Okay, now d plus 2. Now we will use this technique. This is plus sign, so we will use second one. Okay, so second one, e raised to m, e raised to, sorry, just wait. We have to use partial fraction method. Okay, so we shall use partial fraction method. So what is the partial fraction method? Okay, we will find factor. This is the factor of the quadratic equation d square plus 3d plus 2. Okay, so we will use partial fraction. So using partial fraction, you will get 1 upon 1 upon d plus 1 and minus 1 upon d plus 2 into e raised to x. Why is this so? By using partial fraction. By using partial fraction. You know partial fraction how to find? Yes, by using partial fraction.
Yes.
So what is the partial fraction? You know? Yes or no?
Yes, sir.
हाँ, पार्शियल फ्रैक्शन आपको पता है किस तरह से इसको सेपरेट करते हैं, फैक्टराइज करते हैं? नहीं पता है तो आपको बताओ यहाँ पे. See here, this is 1 upon d plus 1 upon d plus 1 or d plus 2. Okay, this, and this can be written as what? A by first factor, that is d plus 1, and plus b by second factor and d plus 2. Okay, what I'm saying here, we have to determine the constant term, that is the coefficient of 1 upon d plus 1. Coefficient of 1 upon d plus 1 is a. Okay, so a will be 1, and if you find coefficient of 1 upon d plus 2, then you will get b equal to minus 1. So we write like this. Now you understood? Yes or no?
सर ए का वैल्यू सर 1 और बी का वैल्यू -1 कैसे आया?
हाँ, अरे यार, just cross multiply it. This is a, okay, and d plus 2 and plus d plus 1 b, and divide by d plus 1 into d plus 2. Okay, so denominator will cancel from this denominator, so you will have 1. Getting? Understood? So now if I putting here d equal to minus, if I putting here d equal to minus 1, so b will be 0. Okay, if I putting a d equal to put d equal to minus 1, so this will 0. So this implies that 1 equal to minus 1. So this will be a, and here will be minus 1 plus 2. That will be what? That will be a equal to 1. Okay, 2 plus 2 minus 1, that is what? 1. So you will get a equal to 1. If you putting here d equal to minus 2, d equal to minus 2, so this will 0. Here minus 2 and plus 1, that is what? Minus b. Minus b here, get this implies that b equal to minus 1. Okay, now replacing the value here, so you will get this factor. समझ में आपको? Yes or no?
Yes, sir.
हाँ. Now just multiply inside. So this is what? This equal to d plus 1 e raised to x minus 1 upon d plus 2 e raised to x. Okay. Now what? Let us go for the next page, or just apply the technique. So this equal to what? We will apply. This is the plus sign, a d plus 1. So we will use second one. Okay. So second one is what? E raised to minus mx. Here m is 1. So e raised to minus x. Okay. Integration of, then x. Your x is what? This thing. So we'll write e raised to x. Okay. Into what? E raised to m. So e raised to m is simply x. Okay. M here, m is 1. So now put here into dx. Okay. Now minus sign. Now apply the second form. So we will have e raised to minus mx. Here m is what? Minus 2. Minus 2x integration of x. Your x is what? Your x is e raised to x. Okay. And into e raised to mx, that is e raised to 2x and dx. Okay. Now what I have to do? Have to integrate it. So let us write one more step. So this equal to e raised to, just copy this in the next page, then you will understand it. Okay. So let us move to the next page first. So this equal to e raised to minus x. Okay. This equal to e raised to minus x, then integration of e raised to x, e raised to x dx, then e raised to x dx minus what is that? E raised to minus 2x, e raised to minus 2x integration of e raised to x into e raised to 2x, and dx. Okay. Is it that? Okay. Now what I have to do? We just write one more step. E raised to minus x integration of e raised to x and e raised to x dx as it is, and minus e raised to minus 2x. Okay. Integration of, see here, this right here, e raised to x into e raised to x, e raised to 2x can be written as e raised to x into e raised to x and dx. Okay, can be written as like this. Yes. Now what I have to do? Have to integrate. So for this we put here, this is the pi. Okay. So put e raised to x equal to what? T. Now differentiate this. So if you differentiating, you will get e raised to x and dx equal to what? Dt. Okay. Now substitute all this thing here. So therefore pi equal to what? E raised to x as it is. e raised to x as it is, because we are integrating only this part. Okay, this is this part kept aside. So integration of e raised to, but e raised to x is what? E raised to x is t. Okay, and e raised to x dx, e raised to x dx is dt. Okay, minus e raised to minus 2x, keep aside, and e raised to x, e raised to x we putting here t. Okay, into e raised to x, e raised to x is t, but e raised to x dx, e raised to x dx is dt. Okay, e raised to x dx is dt. So this is equal to e raised to minus x, e raised to minus x. Just integration of this is e raised to x is e raised to, but here e raised to t, e raised to t is e raised to t, and minus e raised to minus 2x. Okay, integration. Now here we arrange in Lie form. Lie form, that is what? Liate. First we will have algebraic function. First we will have algebraic function, then exponential function. So we first arrange this. So this is t into e raised to t and dt. Okay, now integrate it. So e this equal to e raised to minus x, e raised to t. Okay, and minus e raised to minus 2x. Now apply generalized integration by part. So this is first part is u, second part is v. We write u, that is t. U is what? T. T integration of v e raised to t minus derivative of u 1 integration of v, that is what? Integration of v1, this one, that is e raised to t. Okay, now what? Now just replace t by e raised to x. So we replacing t by e raised to x. Okay, just replace this. Therefore your pi equal to e raised to minus x minus e raised to minus 2x.
सर वो इंटीग्रेशन u into v लगाए.
Just wait. Integration, generalized integration by parts. We are using generalized integration by part. Okay.
सर एक बार वो बता दीजिए ना इंटीग्रेशन जैसे कि u into v का.
ये वाला.
नो
हाँ.
ये
Yes.
जो
Yes.
सॉल्व किए वो
हाँ.
सब जो.
So first of all, we arrange the given function into Lie form. Okay. So we integrate u v dx. Okay. So what is the generalized integration by part? We write u integration of v, that is v1, minus derivative of u, that is u dash, into integration of v1, that is v2. Okay, and plus derivative of u1, derivative of u dash, that is double dash, फिर integration of v2, v3, minus, and so on, like this. You understood this? Apply the formula. Apply the formula here. So t is u, then integration of integration of e raised to t is e raised to t, minus derivative of derivative of t is 1, and integration of v1, is again e raised to t. Okay, here we use generalized integration by part. Okay, now replacing t by e raised to x. So your particular integral become e raised to minus x into e raised to t by what? E raised to x, e raised to x minus e raised to minus 2x. Okay, and t is what? E raised to, your t is e raised to x into e raised to x minus e raised to x. Okay, now just simplify this. So this is what? this equal to e raised to minus x into e raised to x minus, what is the common over here? Common is e raised to x. So e raised to minus 2x into e raised to x common, and we will have e raised to x minus 1. Okay, so this is a require particular integral. Okay, now if you simplifying this, then again you will have, so just simplify this. So what I have to do, just multiply this inside the bracket. We multiply inside the bracket, so just multiply. So this is e raised to minus x into e raised to x minus, so multiply all these things, or just wait, you don't take comma, first multiply inside. Then multiply inside, so the e raised to minus x will multiply e raised to minus 2x inside the bracket. So this equal to e raised to minus x into e raised to x minus e raised to minus 2x into e raised to x into e raised to x minus plus e raised to minus 2x into e raised to x. Now see here, which factor we cancel? No factor. So this equal to e raised to x into e raised to x minus, see here, base is same, the power will be added, so this become e raised to minus x into e raised to x and plus e raised to minus 2x into e raised to x. Now see, which factor will cancel? This is the plus and this is the minus, so this will cancel, getting? So this become e raised to minus 2x into e raised to x. Okay, which is required particular integral of the given differential equation. Okay, I hope you understood this. Have you understood?
Yes, sir.
Only one student replying.
Yes, sir.
What about other student?
Yes, sir.
हाँ, तो इस तरह से आपको इस सॉल्व करना है, ठीक है, बस समझ गया, ओके, ठीक है. नाउ लेट अस डू द अनदर प्रॉब्लम. Let us do another problem. So one problem I want to solve this. I'm not going to ask find particular integral. We solve this problem. Example number 2. Example number 2. Solve the differential equation d square plus 1 y equal to cosec x. Okay, cosec x. So solution for this. What is the solution? First of all, we should copy the given differential equation. So given differential equation, what is the given to you? D square plus 1 y equal to cosec x. Okay, so write down the auxiliary equation. Therefore the auxiliary equation is given by d square. Auxiliary equation is given by d square plus 1 equal to 0. So this implies that d equal to what? D equal to plus minus iota. Okay, these are the roots of the given auxiliary equation. Now we need to find complementary function. Therefore the complementary function is given by the complementary function is given by, what is the complementary function? Roots are what? Complex number. Okay, so your roots is complex number, so you will write c1 cos x yp. So to find the yp of the that is particular integral. Okay, continue. We write here continue. Continue. Okay, yp, this is pi equal to yp, and which is equal to what? 1 upon d square and plus 1 cosec x. Okay, so this equal to 1 upon, so d square plus 1 can be factorized into two part. So first factor will be d plus I, and second factor will be d minus I. Okay, into cosec x. Okay, so I am using here partial fraction method. So use partial fraction. So using partial fraction, you will get this equal to 1 upon 2i, 1 upon 2i in bracket 1 upon d minus I, 1 upon d minus I, and minus 1 upon d plus I into cosec x. Why this so? Because of we are using partial fraction method. By partial fraction. Okay, getting? So the next step will be what? We just multiply cosec x inside the bracket. So 1 upon 2i, so 1 upon d minus I into cosec x minus 1 upon d plus I cosec x. Okay, and just solve this. Here we will use the formula of partial fraction. So we will use here 1 upon d minus m into x wala formula. Okay, just use this. So this is 1 upon 2i, 1 upon 2i, we using here e raised to I x. Okay, integration of x, that is cosec x into e raised to minus ix and dx, and minus here plus, so here will be minus e raised to minus ix integration of x, that is what? Cosec x, and e raised to plus ix dx. Okay, now just integrate this. So before integrating, we write this equal to 1 upon 2i e raised to ix integration of cosec x See here, this can be written as what? E raised to ix can be written as cos x minus I sin x. Okay, this is the complex number I sin x, and dx minus e raised to minus ix integration of cosec x, and this exponential function can be written as what? Cos x plus I sin x dx. Now close the bracket. Okay, now what I have to do? We have to multiply cosec x inside. So cosec x, so this equal to 1 upon 2i bracket e raised to ix integration of, if you multiplying this, cosec x can be written as what? 1 upon sin x. So 1 upon sin x, multiply here, so this become here cos x by sin x, that is cot x. We write here cot x minus 1 upon sin x into sin x, sin cancel, this become only I. Okay, and dx minus e raised to minus x integration cosec x. See, cosec x can be written as 1 upon sin. So 1 upon sin multiply inside the bracket. So cos upon sin, that is cot x and plus 1 upon sine into sine. Sine and sine will cancel. You will have only I. And put here dx and close the bracket. Okay. So now just integrate this. So this equal to 1 upon 2I e raised to ix bracket integration of cot x. What is the integration of cot x? Integration of cot x is log of
Sin x plus
Sin x.
sine x.
Log mod of sin.
Okay. Yes. And integration of dx simply x and minus e raised to ix integration of cot x is log sin x and plus here integration of dx is x. Okay. Now what is common over here? What is the common? See here, this is the minus e raised to minus ix because minus sign over here, huh? So what is the common? Just multiply inside. So this equal to 1 upon 2i e raised to ix into log of sin x minus e raised to ix here I into x. Okay. And minus e raised to minus ix log of sin x and minus I x e raised to I x minus. Getting? Now what is the common here? So 1 upon 2i am
सर एक कट
yes.
जाएगा ना सर e raised to i x log sin x और
हाँ ये वाला
minus
कटेगा टर्म, ये माइनस हो गया. एक मिनट, यहाँ पे प्लस चल रहा है कि माइनस चल रहा है? माइनस चल रहा है. नहीं कटेगा नहीं, जब देखते रहो पहले आप. सो दिस इज द प्लस, ये माइनस साइन यहाँ से मल्टीप्लाई किया तो माइनस ही आएगा, कटेगा नहीं. चलो देखो तो व्हाट इज हियर. सो ई रेस टू एक्स. ओके. मैं अभी देखो इसमें से और इसमें से मैं कॉमन निकालता हूँ. व्हाट इज द कॉमन? log of sin x common. Okay. What is the remaining? E raised to ix minus e raised to minus ix. Okay. e raised to minus ix मैंने ऐसे लिखा. और अभी what is the common here? So just write down इसको. ये माइनस में बाहर निकाल लेता हूँ, माइनस यहाँ से. So minus ix I am taking outside. Okay. Minus ix I am taking outside. So what is the remaining over here? Here e raised to ix minus. So here I am taking minus sign. So this become plus e raised to minus ix. Okay. Now what? If I multiply this thing inside, then what happen? Just multiply karo. So this become log sin x into e raised to ix minus e raised to minus ix divided by 2i. Okay. And minus ix e raised to ix plus e raised to minus ix divided by what? 2i. Okay. Divide by 2 divide by 2i. Okay. Got it? यहाँ से देखो, यहाँ से i और i इसको भगा दो, क्या बचा यहाँ पे? तो इसको मैं क्या लिखूंगा जरा देख लो इधर ही. log of sin x. So this factor become what? This is the formula of sin x into sin x. Okay. And minus x and this is the formula of what? cos x. This is the formula of cos x. Okay, so which is required particular integral of the given differential equation. Okay, so your particular integral is log sin x into sin x minus x cos x. Now this is the number 2. Now adding in 1 and 2, you will get complete solution of the given differential equation. I hope you understood this. Yes, you got it?
Yes, sir.